Hello everyone, my name is Diana. I'm a lab technician in forensic science at the University of Kent, and in this short video I will be showing you some methods for identifying, developing and lifting finger marks. So let's get going. Okay, so we've got three different surfaces in front of us. We've got some plastic, ceramics and glass surfaces, and we're going to be looking at identifying finger marks on each of these three different surfaces and continue with developing finger marks and lifting them as well. So I'll be starting with identifying a finger mark on one of the surfaces using a white oblique light, and then we'll move on through developing these finger marks with different powders. Okay, so we'll start with the glass bottle and a white light torch. All you have to do is just hold the bottle in a position where it's easier for you to identify the actual finger mark, and we're going to use it at an oblique angle. That means a low angle, and all you have to do is just twirl it until you actually find the finger mark, which I just did. The first fingerprint developing technique we're going to be looking at is using aluminium powder on a glass surface. Aluminium powder is very widely used in forensic science, particularly on non-porous surfaces such as glass, windows, different bottles and so forth, depending on whatever surface you've got. It is used with a Zephyr brush. It's made of fiberglass little brushes. And in order to actually develop the mark, you have to use it in a twirling motion. So most of the time the actual brush will be overloaded, therefore the saying less is more is very used in forensic science. Less powder will give you better results most of the time. So if you put too much powder, you risk caking the fingerprint, the finger mark. Right, so the swirling would go very lightly like this, without actually pressing on the surface of the object. Okay. As you can see, the powder didn't actually touch the surrounding of the finger mark, which is what should happen. Because you have to go in very lightly with the brush, it should only touch the surface of the finger mark and not the actual glass bottle. One of the lifting techniques we're going to use today is using a fingerprint lifting tape. This is quite easy to use on any surface that is curved because it's very bendable. And it's got quite a simple usage. You just get your tape, slowly apply it over your developed finger mark, press so you can actually lift the powder, slowly lift it back up, and then we're going to apply it onto a clear acetate sheet, so we can actually confine the finger mark down. And that is it. It is ready to be taken further for analysis. So for the second item we have, the plastic bottle, I'm going to identify the finger mark, and in the same way, it is right there. Okay. And I'm going to be using a fluorescent powder. You can find fluorescent powder in different colors. I've chosen a bright pink one today. And we use an enamel brush with swift motions. Okay, and there it is. Because it's fluorescent, we're going to use a UV light so you can visualize it better. Okay, so we've got our finger mark developed with the fluorescent powder, and I'm going to shine a UV light on it in an oblique angle, just so you can see the ridges that are present and how much fluorescence actually helps the finger mark to be visualized. So the last fingerprint developing powder we're going to use today is a magnetic powder. This is my favorite because it's not as messy as the other ones, and it's quite easy to use on non-porous surfaces, such as ceramics. So we're going to use it on a mug today. The first step, as before, will be to identify our finger marks. I know I've put it around this area, so I'll just show you around where they are. So I've got more than one here. Don't know if you can see them, but there we go. Okay, finger marks identified, and now we need to actually form the brush. So magnetic powder is a powder that is magnetic. The brush we're going to use is a magnetic wand, that's how it's called, and it's got a magnet here at the end which will help pick up the powder and will form a brush. So we'll pick up the powder like this with a magnet. It forms a brush around it, and the most important thing is when you use it to make sure that the magnet that picked up the brush, the powder, will not actually touch the surface, otherwise you risk ruining your finger mark. So it's only with the powder that you should apply it on the actual finger mark. So we're going to apply it now with some just swift moves. I've got quite a lot of prints here. Cool. There we go. Those are our prints. They're easily developed, and in order to get rid of all of the brush that was formed, you just have to extend the plunger back out and it would release the powder. It's easy to clean after it. So you just pick it up and put it back in. Okay. Magnetic powder is best not used on any metals because the powder will just stick to the metal and not the actual print. So make sure whenever you use magnetic powder, you actually use it on something that is not metal. The last fingerprint lifting technique I'm going to show you is with using a hinge lifter. So this is a lifter that is on an actual hinge, so it's got the clear acetate already attached to the tape by a hinge. That's why it's called a hinge lifter. Normally this is best used for flat surfaces, and I know I said the tape is best used for curved surfaces, but just for the purpose of this, in order for me to show you how this works, I'll use a hinge lifter on the mug. So you just have to peel it back this, and it would show this is the sticky side, and all you have to do is just slowly attach the tape to the print. It's really important to press, but don't press too hard, as you might actually move the mark underneath. And slowly lift it back up, and then just close it in. This is like attaching a screen protector on your phone. You just close it in slowly, and that's it. One of the ways we use here in the lab to analyze any collected finger marks is using a visual spectral comparator, or a VSE for short. It's got lights and filters of different wavelengths that can be placed in different positions in order for you to best analyze your sample. It is used for in a lot of different techniques in forensic science, starting from documents, handwriting analysis, to finger marks and so forth, because of its lighting equipment. So I have placed the finger mark that we have developed using magnetic powder in here under a blue light, and I'm going to close this now. So the first setting that I've applied on this is a spot lamp with a blue filter. As you can see, it's not particularly visible right now, although you can see sort of all the ridges present. Then I'm going to try a simple UV. That doesn't really improve much, but let's try a transmitted light. Transmitted light means it comes from the underneath, so instead of on top of the print, it's from underneath the print. Okay, so that's the first transmitted light in the visible range. The second transmitted light in the visible range doesn't work very well, so the first one is probably the best up till now. And transmitted light in the UV range, that works much better as well. So it's all about making the print more visible. We will next be looking at Pathfinder, or ESLA as it's called, electrostatic lifting apparatus, which focuses on lifting footprints from different surfaces. After identifying a footprint at a crime scene, we can use Pathfinder to lift the footprint. The way Pathfinder works is it uses a metal-coated film to cover the test surface, i.e. your footprint. And then Pathfinder applies a large voltage to the film using a metal strip, which will create a charge difference between the film and the footprint. You see, as I applied the voltage, the film flattens out over the footprint, and it creates this charge difference between the film and the footprint, making the dust particles adhere to the film. The moment the control box is turned off, the footprint, the dust of the footprint will remain on the film. Okay, so now we're just going to have a look at the footprint under oblique white light. As you can see, you can make out the shape of the shoe here. It's quite detailed forms as well. We'll probably photograph this or scan it and then send it to the lab for any further analysis to be performed on it. Another technique I'll be looking at is ESDA, electrostatic detection apparatus. ESDA is used to detect certain impressions of handwriting on paper or soft surfaces, and you can even look at fingerprints or footprints and detect them under the right conditions. What I'll be demonstrating today is indented impressions of handwriting on paper. If you write on a piece of paper that is resting on one or multiple papers underneath, then certain impressions can be transferred to the papers underneath and they can be detected through ESDA. Okay, so this is our test paper. We know there's some writing on it, some indentations on it, but we can't actually read it. So we're going to use ESDA to identify what is written on it. So we're just going to put it onto playback. We're going to turn ESDA on. Okay, we're going to apply a Mylar film on it. So the film has to be quite tensely applied, so we won't leave any marks on the paper. Okay? Just going to cut the film at the back. Because of the vacuum that ESDA creates, the film sort of stucks to the bed, gets sucked into it, and you'll be able to create some static charge in the following step. Okay, so this is a Corona wand. Turn it on, and this will apply that static charge that I was talking about to the film and the paper. Applied, going to apply these micro glass beads, which are toner coated. And in contact with that static charge, the toner will be able to get into those indentations and we'll be able to read whatever's written on the paper. Okay, so that's done. After the writing has been developed, I'm going to secure it nicely with a sticky acetate sheet. Okay, so this is the final result. Looking at it, you can see that the writing indentations have been revealed, and there are a few words that overlap each other, which brings us to the idea that maybe there have been two notes on top of this that have been written, but it's way easier to decipher what's been written on it now. A very good thing about ESDA is that all of the evidence that we use at the moment can be reused afterwards, so it is not non-destructive technique. Okay, thank you everyone for joining us. We hope you enjoyed our short overview of forensic fingerprint techniques and contact and trace techniques. Regarding the forensic fingerprint techniques, we have provided you with a short PDF for further fingerprint analysis, and it will show you how to classify fingerprints. And if you want to have some fun at home, we recommend you use some easy powders in order to develop your fingerprints, such as talcum powder, cocoa powder, cornstarch. They're quite easy to use, and just clear tape to lift your fingerprint. And then just use our PDF in order to classify your fingerprints, and hope you enjoyed it.